Hello, good morning friends. So in the last lecture we already learned regular Falsi method. So one example we already saw. The key points of the previous lecture that regular Falsi method is just one formula and it is an iterative method to find out the solution of transcendental equation or sometimes algebraic equation where it is very difficult to find the roots by analytical methods. So now today we'll solve one more example on this. So let us write down one example. So again we'll write use regular Falsi method to solve one function. In the last lecture we already solved with algebraic equation. Now let us take one transcendental equation where trigonometric function is included. So we'll write here use regular Falsi method to solve the following function. Example, f of x is equal to 3x minus cos x minus 1 where a is given as 0 and b is given as 1. Now f of x is 3x minus cos x minus 1. So cos is present, so it's transcendental equation. Now whenever we have trigonometric function, your calci mode should be in radian. I am repeating again. If you have trigonometric function, then your calci mode should be in radian. Now here let us start with solving the problem. What you will do first? First let us write down solution. So in solution f of x is equal to, when you write the solution, write systematically. F of x is 3x minus cos x minus 1, which is given function. Now here initial values is given, a is 0 and b is 1. So let us find out what is f of 0. So 3 into 0 minus cos 0 minus 1 is equal to minus 2, right? Cos 0 is 1, so minus 1 minus 1 minus 2. Your calculation should be in radian. Let us find out f of 1. F of 1 is 3 into 1 minus cos 1 minus 1 is equal to 1.4597. Now if you observe f of 0 is minus 2, f of 1 is 1.597. Okay, now this is negative, this is positive, right? So what we'll do now, if this is positive, this is negative, so we can say that the root lies between 0 and 1. So we'll write regular Falsi method formula again. X1 is equal to a into f of b minus b into f of a divided by f of b minus f of a. This is the formula of regular Falsi method. Now put the value of a and b. So in the first iteration, what is our a? A is equal to 0 and b is equal to 1, right? Because we already know f of 0 is minus 2 and f of 1 is positive, so a is 0, b is 1, positive negative sign. Now once you get this, let us find out x1 is equal to, put the value of a as 0 into f of b is 1 minus, we are just putting the value of this a and b in this formula, so we got this one. Okay, now after this let me write x1 is equal to 0 into f of 1 is 1.4597. So this is our f of 4.597. Substitute here. So we get this divided by 1.459 minus f of 0 is minus 2. And this is equal to, if you use calculator, with the help of calculator, we get the value of x1 is equal to, what is the value? Calculate it. Take your time. What I will suggest in this video, when you are solving it step by step, you stop the video, find your answer and then cross verify. Okay, don't just see the video, do it. Take the calculator with you and let us solve. So 0.5781. In the next step we'll find out what is f of x1 now to decide new a and b. So f of x1, that is f of 0.5781. so this is negative, now this is positive, this is negative, so our root lies between these 2 points. So a is 0.5781, b is 1. Therefore again we'll write the same, we'll write for the formula of regular Falsi, that is x2 is equal to a into f of b minus b into f of a divided by f of b minus f of a. After every iteration I am writing the formula because my aim is that in the lecture itself you will learn the formula. That's why I am repeating again and again. No need to go and study and memorize separately. Some students may require, but I think I am repeating almost 10-15 times in the lecture, so it's very easy to memorize. The bombarding is going on that formula. So Let us solve second iteration now. We know the value of a is 0.5781, b is equal to 1. Therefore, x2 is equal to, put the value of a and b in this formula. So, we'll get 0.5781 into f of 1 minus 1 into f of 0.5781 divided by f of b. B is 1, so f of 1 minus f of 0.5781. This is equal to, enter. So solve now. Put f of 1. We know f of 1 is equal to this. Then substitute the value here. Minus 1 into f of 0.5781 is minus 1.0132. Substitute this value here. So 1.4597 minus 0.1032, and this is equal to x2 is equal to, calculate. Yes, yeah, so value is 0.6060. Now if you observe, x1 is 0.5781, x1 is equal to 0.5781, and now x2 we have 0.6060. So both are not same, so we have to go for third iteration now. Okay, so for third iteration I will enter again. Let us start third iteration. So as I already told you, I will repeat the formula. So again we know the regular Falsi method. X3 is equal to a into f of b minus b into f of a divided by f of b minus f of a. Now we know the value of a and b now. So here in the third iteration, a is 0.6060, b is 1. I think it is clear now for all of you why a is 0.6060, because this is 0.6060 is negative and f of 1 is positive, so the root lies between this and this point. So a is 0.6060, b is 1. Now after this we are just putting the values here, a and b values, and therefore we obtain here this expression. Now simplify this expression. So enter. X3 is equal to 0.6060, which is already given. Put the value of f of 1 as 1.54, this one here in this formula, minus f of 0.6060 is minus 1.0390. Substitute all these values in this formula. So 1.4597 minus f of 0.6060 is minus 0.0039, and if you use calculator we will get the answer. So x3 is equal to 0.6070. Again if you observe, now the value is 0.6070, right? This is our x3, and our x2 is again different, right? So x3 and x2 both are not same, right? Therefore we have to go for one more iteration. So we have to go for one more iteration. So let me write. Iteration is again the same formula. X4 is equal to a into f of b minus b into f of a divided by f of b minus f of a. Now let me write fourth iteration. Now the method is very simple. It's very simple method. Only the formula is important. Choose a and b. Now what you will choose a and b? Can you tell me? A is 0.6060 because negative, and then f of 1 is positive. So again the value is between 0.600 and 1, because this is also negative. This is negative, right? Now therefore, and always remember a is less than b, so it's very easy for you to identify which is a and which is b. Condition a and b, f of a and f of b both should be of opposite sign. That is only one important thing to solve such type of problem. Now next again we put the value in formula x4. So a is 0.6070 into f of 1, because b is 1, minus b is 1 into f of a is 0.6070 divided by f of b. F of b is f of 1 minus f of a. A is 0.6070, so f of 0.6070. Now we put the values of each function now. This function, this function, this function. So we'll get x4 is equal to 0.6070 into f of 1 is 1.4597 minus 1 into f of 0.6070 is minus 0.0004 divided by f of 1 is 1.4597 minus f of 0.6070 is minus 0.0004, and if you use calculator you will get the value as x4 is equal to 0.6071. Now we observe in the previous iteration we were having the value of x3 is 0.6070 and this is 71, so both are not same, so we need to perform one more iteration. So let us write one more time. So we'll write again the formula x5 a into f of b minus b into f of a upon f of b minus f of a. So in the fifth iteration, what is a and b now? A is, yes, 0.6071, b is equal to 1. Now here f of 0.6071 is itself to 0. So actually we got the solution here. But if you put the values, we get the same. A into f of b. So a is 0.6071 into f of 1 minus b is 1 into f of a, f of 0.6071 divided by f of b. So f of 1 minus f of a, f of 0.6071. Now put the value of each term. So what you will get? X5 is equal to 0.65 0.6071 into f of 1 is 1.4597 minus 1 into f of 0.6071 is 0 divided by f of 1 1.4597 minus f of 0.6071 is 0, and if you calculate this value, therefore finally we get x5 is equal to 0.6071. Now if you observe, now x4 in the previous situation, what is the value we got? We got x4 is equal to 0.6071. Here also we got the same value. So x4 and x5 both are same. So we can claim that therefore the root of the equation is 0.6071. So today we have solved one more example on regular Falsi method. Now with the help of this iterative method, now you can solve n number of problems. You have to practice at home. These are some examples for practice. You can try these two examples and solve it, and then you can submit it to me. Then we'll see how many of you can really understood the topic. Okay, thank you.